Good day, viewers, and welcome to your best learning hub for the sciences, Jallo Science Academy. I am Mohammed Jallo. In this tutorial, I'll be taking you through questions that were posed by one of our viewers on variation, questions that has to do with increase and decrease percentage-wise in variation. Stay tuned as I take you through these questions. So this is the question. It reads, if A varies directly as the square of R and V varies directly as the cube of R, find the percentage increase in A and V if R is increased by 20%. The relation given to us is A is proportional to R squared. So being that A is proportional to R squared, we can get rid of the sign of proportionality by saying A is equal to KR squared. Now this R, we are told in the question, is increased by 20%. But before it was increased, the original R stands at 100%. After the increase, we now have a new R we call R prime. It will be equal to, it is going to be the increase plus 100 divided by 100 multiplied by original R. So R prime here will be equal to, this plus this will give us 120 divided by 100 multiplied by R squared. So this 0 and this 0 cancels, and 12 divided by 10 gives you 1.2. So meaning our R prime will give us 1.2 R squared. So now if we want to fit it into this equation, it can now be A is going to be equal to, well, mind you, this is squared, so this one is going to be squared. So we can say A is equal to 1.2 squared and then KR squared. 1.2 squared, use your calculator, 12 squared, you get 144. So 1.2 gives you 1.44 squared. So A is equal to 1.44 KR squared. So this is what we've gotten as the new area. So we can refer to this as A prime. This is our new area. This is the original area that we had. Now, we want to know the percentage increase in the area. So for us to know the percentage increase in the area, percentage change in area, of course, it is going to be the change over the original multiplied by 100%. So the change is new minus original over the original multiplied by 100%. So this implies the new we have is 1.44 KR squared minus the original we had is KR squared over the original KR squared multiplied by 100%. So we have KR squared here, KR squared. So we can factorize KR squared out. So if we factorize KR squared out, we'll get 1.44 minus 1 all over KR squared multiplied by 100%. So KR squared and KR squared will cancel. We'll have here 1.44 minus 1 gives us 0.44 multiplied by 100%. Therefore, the percentage change in area is going to be equal to 44%. So this is by how much the area increased in percentage. It is 44%. Okay, so this is for the area, and we are told that also V is also proportional to R cubed. So working V is proportional to R cubed, V here being proportional to R cubed. We try to get rid of this sign of proportionality and we introduce a constant. So V will be equal to KR cubed. So V being equal to KR cubed here, the R stands at 100% before the increase. So our new R is now going to be the 20% plus 100% over 100 here multiplied by R cubed. So this will give us R is equal to 120 over 100 multiplied by R cubed here. So this 0 and this 0 goes. So we will have R to be equal to 1.2 R cubed. So this is our R prime, right? So for us to get the new volume now, the new volume, which will be V prime, will now be equal to KR cubed multiplied by, go for our calculator, 1.2 cubed, 1.2 cubed will give us 1.728. So we get 1.728. That means V prime is equal to 1.728 KR cubed. So now we try to work out the change in area. So you can take a screenshot of this. I'm going to clean this one. So in this situation, for us to get the change in the percentage change in volume, of course, is the change over the original multiplied by 100%. And the change is the new minus the original. The new we have is 1.728 KR cubed minus the original we had is KR cubed divided by the original KR cubed multiplied by 100%. So factorizing KR cubed out, KR cubed, we get 1.728 minus 1 over KR cubed multiplied by 100%. So this guy and this guy here cancels. 1.728 minus 1 gives us 0.728 multiplied by 100%. So this multiplied by 100, move the decimal 2 places. So we get 72.8%. Therefore, percentage change in volume is equal to this. So this simply means R, the area here, increased by 44% and the volume increased by 72.8%. So this is the solution to this question. Okay. So we're moving over to the next question. Okay, this is the question that we have. Three variables, P, Q, and R, are such that P varies directly as Q and inversely as the square root of R. Find the percentage decrease in P if Q decreases by 4% when R increases by 44%. So I take you through the solution. And we write the relationship between them, okay? That P varies directly as Q and inversely as the square root of R. So this means P here is directly proportional to Q and inversely proportional to root of R. So we can get rid of the sign of proportionality and we introduce a constant K. So P will be equal to KQ over the root of R. But we are further told that we should find the percentage decrease in P if Q decreases by 4% when R increases by 44%. So we need to get our new Q, okay? We need to get our new Q. So getting Q is decreasing. So it is going to be 100 minus the percentage by which it is decreasing, which is 4%, expressed over 100 multiplied by our original Q. So Q prime will be equal to this minus this gives us 96 over 100 multiplied by Q. So Q prime will be equal to 0.96 Q. So this is what we get as our new Q. Now let's go for our new R. So for us to get the new R, it's going to be R prime is equal to 100 plus 44. We are adding because it is increasing, okay? Over 100 multiplied by root of R, which is the origin. So this implies that R prime is equal to 144 divided by 100 multiplied by root of R. So 144 divided by 100, R prime will be equal to 1.44 root of R. So this implies we can say R prime is equal to the square root of 1.44 R. But we can simplify this further by saying R prime is equal to root 1.44 multiplied by root of R. Root 1.44 is a perfect square because square root of 144 is 12. So R prime will be equal to 1.2 root of R. So this becomes our new R, which is R prime. So now we use the formula which says percentage change in P is going to be equal to the new minus the original all over the original multiplied by 100%. So now the change is going to be the new. We have the expression to be P is equal to KQ upon square root of R. So now we can write K, but the new value for Q, which is Q prime, we have it to be 0.96Q multiplied by 0.96Q all over root R. The new expression for it is 1.2 root of R here minus the original, that is KQ upon square root of R all over KQ upon square root of R multiplied by 100%. So now what we do here, we're seeing KQ and the denominator of root R, KQ denominator of root R. So we can factorize KQ root R out. So we say KQ root of R will be factorized out into, here we get 0.96 divided by 1.2 minus 1 multiplied by 100% here all over KQ upon square root of R. So this guy and this guy cancels. We are left with 0.96 divided by 1.2. 0.96 divided by 1.2. We have it to be 0.8. So we get 0.8 minus 1 multiplied by 100%. So this implies 0.8 minus 1, that gives us negative 0.2 multiplied by 100%. So we have it to be negative 20%. This negative value tells you that P is decreasing. Okay, so in writing our final answer, we are going to neglect that negative sign. So therefore, P decreases by 20%. Meaning, so the answer there is 20%. So if Q decreases by 4% when R increases by 44%, the meaning P is decreasing by 20%. Thank you very much for watching our video. You can like our video, subscribe to our channel if you're new, hit the notification bell to be notified each time we release a new video. You can as well drop your comments in the comment section below. You can follow us on Facebook. It's a very active Facebook page, Jalo Science Academy. And as well on Telegram, you can follow us on Telegram by joining our channel. So thank you very much for watching this video. Share these videos to your colleagues. And don't forget, never stop learning. Because the last time I checked, those that have stopped learning have stopped living. Thank you.